I want to solve this integral by changing the order of integration. So first thing to notice is this goes from y equals x squared over 3 to y equals 3, and x equals 0 to x equals 3. So if we look at the graph here, the blue line is y equals 3, the red is x squared over 3. So x is going from 0 to 3. So these are all the x values. And then y is going from x squared over 3 to 3. So x squared over 3 is this, and it stops all the way up to 3. So this is the region that we're interested in. Okay. So in order to change the order of integration, we want to do dx first. So think of your rectangles as being horizontal. So now it's all going to be in terms of x. So it's like x equals something to x equals something. And the way you do this is you have to go from left to right. The bottom limit will be on the left side. So what is bounded on the left side? Well, that's clearly the y-axis. And the equation for the y-axis is x equals 0. And what is it bounded from the right? Well, it's bounded by the red parabola, x squared over 3. But notice, this is in terms of x. I want to solve for x, not solve for y. So I'm going to have 3y equals x squared. So x is going to be plus or minus the square root of 3y. Now the question is, do we include both or one of them? So right now, our region is in the first quadrant. What do you know about the first quadrant? X and y are both positive. So clearly, that only happens when x equals square root 3y. So that's going to be our upper limit. Okay, now for the limits of y, we want a solid number here. So this won't depend on any function. So what is the smallest of y is? Well, clearly it's 0, right? Because it's 0, 0. And then it increases all the way up to 3. Okay. So the minimum is 0, and it goes all the way up to 3. And now we have to do the antiderivative. Okay, so first we're going to integrate with respect to x. So square root of y cosine y, you can treat it as a constant. So the antiderivative of a constant is a constant times x or y, depending on what you're integrating with respect to. So we can treat this as square root of cosine y times x. Okay, and then we're going from y equals 0 to y equals 3. Now for this inside integral, we're going from x equals 0 to x equals square root 3y. Okay, so I can factor out the constant, and I'm going to plug in square root 3y, and if I plug in 0, I get 0. So there's no point of plugging it in. And then I'm going to integrate from y equals 0 to y equals 3. Okay, now I can simplify. I have square root of y times the square root of 3y. You can think of this as the square root of 3y squared, which you have square root 3 and then times y. Okay, the square roots will cancel. And now we have cosine y left. And that goes from y equals 0 to y equals 3. Okay, the next thing is we can factor out the square root 3 because that's just a constant. Okay, so let's see how that looks. We have square root 3 times the integral from y equals 0 to y equals 3 of y times cosine y dy. And for this one, we need to use integration by parts. We'll say u equals to y. Du will then be dy. dv is cosine y dy. And so v would just be sine y. So we still have the square root 3 outside. And now we're going to multiply uv, which is y sine y. And here we have to evaluate it from y equals 0 to 3, minus integral v du. So that integral goes from 0 to 3. And that's just sine y dy. Now I'm going to multiply this out. So I'm going to plug in y equals 3. It'll be 3 sine 3. If I plug in 0, it's just 0. Because 0 times sine 0 is 0. Minus, find the antiderivative of sine y, which is negative cosine y. We're going to evaluate it from y equals 0 to y equals 3. The two negatives will make it positive. So it's the square root of 3 times 3 sine 3 plus cosine 3 minus cosine 0. So then this is 3 sine 3 plus cosine 3 and then minus 1. And this is the exact answer.